Hi everyone, we're back with a new math problem, but what we're dealing with today is a bit different from what we usually deal with. So what we have is if r is equals to 1, meaning if the radius of all these circles is equals to 1, then what is the approaching limit of the area? So what we have here is some circles labeled A1, A3, A4, A5, A6, and I mean A10. So if you notice, A3 is the circle with the triangle in it, and the triangle has 3 sides. A4 is the circle with the square in it, which has 5 sides, and the same for A5 and A10. So what we're doing is we're approximating the area of the circle using these different shapes. So over here, our first polygon is a triangle, and it has 3 sides. So we figure out the area of the triangle, which would approximate the value of the area of the circle. But since this isn't really close to the area of the circle, because you can see there's a lot of this area over here that's being left out. So this isn't really close, and this doesn't really give us the exact value of the circle. But as we increase the sides of the polygon, which we have over here, a square and then a pentagon and then a decagon, you can see that the area that is being left out gets lesser and lesser each time. So we only have this much area in this one, and in the pentagon there's not much area. And then moving on to the decagon, you can see there's barely any area that you can see. So what we're doing is we're just increasing n, which is the amount of sides of the polygon, to get closer to the value of the area circle. So how are we going to solve this? Let's go ahead and notice how we're going to figure out the area of the circle using these polygons. If we take the center of the circle and we divide each polygon into separate triangles. So the triangle one right here works like that. And then over here we have our square that gets divided into 4 triangles. And then the pentagon gets divided into 5 triangles. And then the decagon gets divided into 10 triangles. Okay, so what is the area of a triangle? Well, there are many different formulas for finding the area of a triangle, but the one we're going to use here is 1 by 2 times AB times sine theta. So over here, what we're going to have is this is going to be theta, this is going to be A, and this is going to be B. So all we're going to need to know is the length of 2 sides and the value of the angle that intersects at the intersection of those 2 lines. So over here, like in our first triangle, in our first figure, A3, we know the value of this because since this is a 360-degree angle divided into 3 parts, we can tell that this is 120. And since this is the value of, this is A, and A is the same thing as the radius of the circle, and we know the value of the radius of the circle, which is 1. Same with B. So we know the value of A and B, and we also know the value of theta. So we can go ahead and apply this formula on our first figure. So let's go ahead and do that. We have A3, so we'll just apply the formula on our figure. I'll move this over here. So A3, we will multiply 1 by 2 times 1, which is A, and B, which is 1 again, times sine 120. Now, you could use a calculator for this, but I have it off the top of my head. So 1 by 2 times sine 120 is root 3 by 2. But then if you notice, there are 3 of these same triangles. One here, and then one right here. So we'll go ahead and multiply this by 3, which would give us 3 root 3 over 4. Now, we could go ahead and keep it that way, but I'm just going to keep it in this way. Now let's go ahead and do the same thing for A4. So for A4, the only difference is going to be the value of theta and the number of times we multiply it by. So that would give us 1 by 2 times 1 times 1 times sine 90, because it's being divided into 4 parts. So 360 divided by 4 gives us 90. So 1 by 2 times 1 times 1 times sine 90. Now sine 90 is 1, simply 1. So that would be our answer. But since there are 4 of these same triangles, we would multiply this by 4. Then again, we could do the same thing for A5. This is the last figure we're going to do this for, so that would give us 1 by 2 times 1 times 1 times, 360 times divided by 5 is 72. But let's go ahead and we could do this for a long time and just do this until we can see an approaching limit, but that's not what we're going to do. So what we're going to do is we're going to take a different approach to this. We're going to look at what we have over here. So right now we have 3 root 3 over 4 for the area of A3, and then we have 1 by 2 or 4 by 2, which gives us 2. Now, if you think about it, we could write n. So let's take a value n. So n would be the number of sides. So over here, n for A3 would be 3, n for A4 would be 4, and then n for A5 would be 5. And this would simply go on, and then n for A10 would be 10. So we're going to take a look at this and this, and you can notice that our formula is basically 1 by 2 times sine 2 pi by n. Now this probably looks pretty complicated. Times n. So this probably looks really complicated, and don't worry, I'm going to explain this. So 1 by 2 is simply the 1 by 2 that we have over here, and here. So this is 1 by 2, and we simply put it back. Now sine 2n by n. 2 pi by n. So 2 pi is 360 because the value of pi is 180 degrees. So 360 divided by n, which makes sense because the number of sides is also the number of triangles in the polygon, meaning that we would divide 360 by the number of sides in the polygon. So that would give us 2 pi divided by n to find the angle times n, because that's the number of triangles in that polygon. So now what we need to do now is find the approaching limit. So what is the approaching limit? For n goes on to infinity, so we can go ahead and put down the value of n as infinity. But if you're familiar with trigonometry and calculus, then you would know that there is a formula given that for lim where theta tends to infinity, sine theta divided by theta is 1. So how are we going to use this? Well, I'll show you. What we have over here is the limit n tending to infinity, 1 by 2 times sine 2 pi by n times n. So what does this do? Well, this is pretty much what we have over here. And what we're going to do is we're going to multiply this by 2 pi by n. You'll see why I'm doing this in a minute. So 1 by 2 times sine 2 pi by n times n times 2 pi by n. And then we'll divide it by 2 pi by n to cancel it out. So you can see that this 2 and this 2 cancel out. This n and this n cancels out. Okay, so this leaves us with sine 2 pi by n times pi, the pi right here, divided by 2 pi by n. Now, using this formula over here, the one that I've circled, we can write this as 1 times pi. And this gives us pi. Now, if you've been following along, this would probably make really a lot of sense. And even if you didn't, well, I'll explain why this makes a lot of sense. We all know that the area of a circle is pi r squared. Now over here, our value of r is 1. So this would be pi times 1 squared, leaving us with pi. So the area of a circle with radius 1 would have an area of pi. And using our polygon method, we figured out that the approaching limit of, well, the area of the circle is pi. So this makes a lot of sense because we could use this method to find the value of a circle. Now, you could try doing this problem with a circle with radius 2 or 3 or 4 or whatever, and you would find that the answer would be the number squared times pi. So thanks for watching this video, and well, if you liked the video, be sure to drop a like and subscribe. Thanks for watching.